Why is everything around us generate sound? Also, there are a whole variety of sound. Running water, cell phone, music, and even someone's voice. The list of sound you hear every day is endless. But when you are shown that sound look like this, but what you know is that sound is like this. Well, it's okay. This time we're going to answer what is sound.
Hi, my name is Maria Sitlaki Alecha Baldovina, and this time we're going to have an experiment involving mechanical waves and sound. So, what is sound?
Let us start in a simple sound. That was popping an inflated polka dot balloon. This polka dot balloon is filled with high pressure air particles, and when popped, all these particles rush out and hit the adjacent air particles. Those particles hit the next air particles, and so on, thereby creating and expanding shallow air particles just bouncing into one another, and this is called pressure wave or sound wave. Bouncing air particles apply a force to your eardrum, which causes the part of your internal ear to move. Then your brain processes this motion from your internal ear and tells your cognition that, oh, this motion in my ear sounds like popping a balloon. Sound is a wave. It is a vibration that travels through a medium like air or water. If you drop a rock into the water, you disturb the surface of the water and create ripples or waves, which travel away from the impact. The ripples cause the change in water, the ups and downs. In sound, these waves are visible without our eyes and have number of properties. Crest, they have a maximum point called crest. Minimum point through. Wavelength, it is the distance between the particular crest to the next one. Amplitude, which is the distance from center line to the top of the crest and bottom line of throw. Frequency, which is the number of waves to pass in a fixed point per second. Speed is the wavelength times of frequency.
In our experiment, we only need three different bottles. I have here Red Horse beer bottle, a UFC bottle, and also have here the efficacent oil bottle. So it depends on what bottle available in your house.
Two sets of waves of the same amplitude and the same frequency, which are propagating in the same medium but in opposite directions, overlap. In a stationary wave, each point of the wave performs oscillations around the position of equilibrium, but the amplitude of the oscillations depends on the location of a given point. The points, known as antinodes, oscillate from a position of equilibrium to a maximum distance which is equal to twice the amplitude of the overlapping waves. The points, known as nodes, however, always remain in the position of equilibrium. All other points perform oscillations with an amplitude which is lower than the maximum.
How to produce sound with the use of bottles. Simply put your lips on the top of the bottle like this, and then blow as you want. And yes, it sounds like that. And you do the same thing with a different bottle. So let's try UFC bottle. It sounds different, right? And I am expecting this one sounds higher than this one. Oh my god. Did you know that hitting the bottle produces sound? So let's try with the pen hitting the bottle. Yes, it sounds like that. And I noticed that when I hit the bottle, it's moving, like it's vibrating. And I concluded that when I hit or apply force to the bottle vibrates and it produces sound. And also, blowing the bottle is different from hitting a bottle. Because hitting the bottle vibrates and it produces sound. While blowing the bottle like this is applying force or applying air inside the bottle that vibrates and produces sound. So, it's different from hitting and blowing the bottle. The vibrates is applied on the bottle, and when blowing it is the vibrates happening in the air and it produces sound. That is our experiment of the day. So I am Maria Sweetlaki Alecha Baldovino, a Bachelor of Secondary Education student from SDSSU Main Campus. And I hope you've learned something from me, and I hope also that I explained it well for you to understand sound more. And see you in our next experiment. Bye!